Here. Okay, so you see me now, or you see yourselves?
Yes, we can see you. Yes.
Okay, cool.
You know, in Google Hangouts, they switch between the two different screens. So we can try to make it as a conversation, but anyway, I can close the mic. So
Oh,
you all.
we don't have to. Like, I don't have to show slides. We can just have a conversation.
Okay. Like, feel free to switch between both as you like.
What do you prefer? What do you prefer?
I think like sharing like some presentation on in between would be nice, so they can get more idea the bigger picture.
Okay, in between.
Yeah.
Okay. Well,
if you
I
have
guess
a question, you can start right away and present it.
Okay. Should I start with my slides?
Yeah.
Okay.
Yes.
Okay. So yeah. Well, thanks for having me. I'd love to come to Egypt one day. So maybe this will be the start. So
yes.
Yeah. So let me just tell you a bit about like my background, and then I'll show you some of the work that I do, and I'll try to keep it short, so we can actually just have a conversation. I kind of started in music technology, so I was really interested in recommender systems. So this is how to predict or how to recommend music for people. So if you know what kind of music somebody likes, how can you recommend more music that they are going to like? And this was how I started in machine learning, because I was really interested in finding new music, and I was looking at these systems online like Last.fm and Pandora that did music recommendation based on machine learning. And so I decided I needed to learn machine learning. And once I started working in that field, I became interested in some of the more artistic applications of music technology, because a lot of people who are doing machine learning with music are interested in, these academic scientific questions. But there's also a lot of people who are interested in things like musical instruments, or new ways of performing, and things like that. And so I started getting into this, and these are just some pictures of projects that I've done with friends of mine, trying to create new instruments, for new electronic instruments for musical expression. And so that led me to, yeah. Oh, okay. If you have any questions, just call out.
Okay.
Yeah. So I became interested in machine learning, and because I was doing this creative music technology stuff, I became interested more broadly in art. And I've always been trying to find a good reason to justify this. I think for me, art is a really, really great way to get insight into mysterious, unknown,
unknown, so
interesting technology. Yeah. A little bit of an
Well, with you, we just had a technical issue with the audio. That's why we came closer. So right now, the audio is great, and we're fully focused with you.
Okay. Yeah. There's quite a bit for myself. Thing. Okay. My slides. So basically, I'm interested in projects like where I would try to learn interesting things. So here I go Google search of a bunch of holidays and fruits and birds, and then using called a recognizing map in order to visualize the. And I've always been this idea of getting this sort of pipeline, right?
We think people
has
having
collective consciousness,
perception,
and that we
and
can
that we can
learning
learning
actually try to put it on paper, what it looks like. So what
So what
different words like, what colors do we associate with them? What are the sort of shapes that are associated with different words? And so this is kind of what I became interested in. So I'm going to skip a little bit of this neural network stuff. This is a lecture that I often do introducing neural networks. We don't have enough time for it. But neural networks are the sort of primary way of doing machine learning. And they're kind of these algorithms that can convert one kind of data into another kind. And so that's very generic, but the most obvious application of that is taking an image and converting it into text that represents the image. So what is inside of that image? And they have lots and lots of really cool properties. I'm just going to show you some things that I'm interested in. So one thing that I really love about neural networks is that you can make interesting visuals with them. And about 10 years ago, there was some research into trying to visualize what neural networks learn. And the way that you can do that is by trying to synthesize images which activate parts of a neural network. So let's say you have a neural network that can detect dogs, or it can detect can detect cats or dogs or lemons or limousines. So maybe what you can do is to try to create an image which will maximally activate that neuron in order to see what that neuron is looking for. So this all came out of research work for exactly that purpose, and also for security, because there's a lot of work that's interested in how people can trick neural networks. And it turns out that you can feed them what are called adversarial examples. And those are basically images that have been slightly modified in order to trick the neural network into thinking that it's something else, in a way that humans can't really perceive. And this research, although it's very, very scientific and has very practical applications, is what led eventually to Deep Dream. And Deep Dream was this thing that was a technique for using exactly this, except to make interesting artworks. And so Google kind of pioneered this technique, but it's been sort of sitting in the research for a few years before that. And so this is some of their work that went from friends of mine, Alex Mordvintsov, Chris Ola, Mike Taika, who first came up with the Deep Dream technique and have since become all friends of mine. And this is some of the work that Alex and Mike Taika in particular were doing, just creating art from this technique. And so I became interested in it, and I started to add my own twist to it. I started experimenting a lot with mixing the different filters, because neural networks have a lot of filters in them that look for different things. And so I became interested in kind of like what you could do to maybe mix, to compose with them. So this comes from trying to visualize two neurons at the same time, but then using these masks in order to blend them together. And so you can arrange the masks in a lot of ways. So here they're arranged in circles. And so you get a lot of different cool sort of effects. You can also make video with it. I don't know how well you can see this on your screen, but it's a video which is using a feedback loop in order to make every single frame. I'm actually making one of these today for somebody else. And I figured out a while ago how to make loops. So here, these are actually, each of these videos that you're looking at are actually just 3 seconds long. They're infinite loops. They just go over and over and over, and you can't ever really tell what's going on. It never really ends, but it's actually just 3 seconds long. And this is similar. Also, these looping videos that you can create. So I'm also interested in this idea of style, and so there's a lot of work that goes into transferring the style of one image over another. So this is the Mona Lisa in the style of Cubism, Van Gogh, and Monet. And this idea of style transfer can make visuals, really interesting visuals like this. I also have used this as an installation several times, something called Style Transfer Mirror or Cubist Mirror. So basically you can get in front of the mirror and then see yourself in the style of some famous iconic painting. So like Hokusai, or, this is Kandinsky, so very abstract, and so on. So this is closely related to style transfer, is this idea of texture synthesis. So here, this is very similar actually to Deep Dream. It's basically just generating textures that look like they came from a particular source. And so this looks like Google Maps, but it's actually not anywhere in the real world. It looks like Google Maps, but it's actually just a texture synthesis. And here you can see also that there's a, you could also loop these. So this is sort of, it looks like you're always zooming in to Google Maps, but it actually never ends. So this is just an infinite loop. So I'll prove it to you. You see the bar here? It just rotates around and around and around. And this is the same thing except Hokusai. So like an infinite loop going into Hokusai videos and Kandinsky videos. Jackson Pollock. So this is basically a texture synthesis that's kind of a composite of many works by a single subject, like Jackson Pollock. So it looks like a new Jackson Pollock painting, but it's basically composed from his other paintings. This is the same thing except Frida Kahlo, Salvador Dali, Georgia O'Keeffe, and other artists. I'm also really interested in generative models, and these are basically this technique for training a neural network to represent a particular set of images such that you can generate new images that look like they came from the original data. And this is really important for scientists because they're always interested in trying to model that which they cannot trying to model things because it helps them understand how they work, right? So this is the quote by Richard Feynman: "What I cannot create, I do not understand." And generative models kind of belong to a few different categories. There's what are called autoencoders, variational autoencoders on the left, which basically try to learn a generative model by compressing data, learning a sort of encoder that compresses the data to a smaller amount of data, and then a decoder which can take that small subset and then expand it outward back into pixels. And then there's an even weirder technique called generative adversarial networks, which basically use two neural networks locked in this competitive process in order to learn a decoder, a generator that is able to create images that look like they came from the data. And you can do interesting like sort of arithmetic on the features. So you can do things like find the part of the network that creates a man with glasses and then subtract just man and then add woman, and you get man with glasses minus man plus woman equals woman with glasses. So this is kind of an interesting property. The first time I used, again, a generative adversarial network in some sort of a piece, like an art piece, was in a project called A Book from the Sky, where I basically trained one of these generative adversarial networks, one of the first implementation of one that was on GitHub, on Chinese characters. So if you've ever seen Chinese characters, they look like this. And then what you're looking at are pairs of characters where the one on the left is real. It was drawn by a human being. And the one on the right is fake. It was synthesized by the generative adversarial network. And so you can do these animations and synthesize fake characters, right? So these look like they were handwritten by people, but they were actually generated by the network. And you can do interpolations between the different categories here. So here I'm oscillating between people and culture, between different groups of related words, and some of which share interesting characteristics with each other. Now that was from 2015. In 2017, NVIDIA was able to create GANs that synthesize samples up to 1024 pixels. So these things went from 32 pixels to 1024 pixels in just 2 years. And so they continue to go higher and higher resolution. They're becoming more and more realistic. These are synthesized on faces, and really, really like just getting to be pretty incredible. And this is more of their work, progressively grown NVIDIA GANs. I trained one of these on paintings. So this is an animation which shows a 1024 pixel generative adversarial network that was trained on paintings. So 100,000 paintings, which I scraped from this website, WikiArt. And then I trained again to produce fake paintings. And this is what that looks like. And you can see that a lot of these images look realistic. They look like real paintings. They show different styles. You know, they show landscapes and portraits and abstractions and so on. So it's really, really, really getting to be quite impressive and realistic. Right, and these are just some stills from there. You can see that it has a lot of diversity. The model can capture, you know, abstract works. They can capture document archives and portraits and surrealist paintings and landscapes and religious iconography and so on. And they just continue to get more and more realistic. Cheeseburgers, dogs, these are totally fake. So this is big GANs that were trained on lots and lots of images. So we're really getting to the point that this stuff is really getting to be quite realistic. Dogs and so on. And there's a lot of neat things you can do, mixing and matching different dogs and animals together. So again, there's this whole aspect of feature arithmetic that's really quite interesting. So let me fast forward through this, and yeah, I'll show you just one more thing, and then maybe we'll pause for questions. So here, this is actually regenerating a video from the Discovery Channel of all things on on images that look like of monkeys and so on, monkeys and different animals and creatures. And so this was from a few months ago as well. Let me pause here, and maybe we can pause for if there's any questions on what I've been sharing so far. Can you guys hear me? I can't hear you anymore.
So we've got some questions here.
Oh, great. Oh, great.
Yeah. So who would like to start? We've got a question. Yeah.
Show the neural synthesis.
The neural synthesis. Yeah.
It look like reaction diffusion.
Mm-hmm.
Is it like reactive diffusion? Diffusion?
Yes. Or it's another.
Well, maybe it's similar, but it's actually very. So it's using a neural network to synthesize the image rather than some sort of like feedback loop procedure like you see with reaction diffusion. So maybe it looks like in aesthetic, it looks maybe kind of similar, but it's not at all using a similar technique.
Yeah. Use this. What technique did you use in this project?
I can't hear too well. Maybe.
Yeah, she's asking which technique or what program you used to create that kind of synthesis.
Yeah, it's all code. So there's no like application that does that yet anyway, but I'm using basically TensorFlow, starting from an example of the technique Deep Dream. So there's some code that you can find online that does a basic version of this that's inside of the TensorFlow main TensorFlow repository. And then I'm just adding a bunch of stuff. Good. Yeah. Anybody else?
Sorry, can you just repeat the last part because the internet just kind of froze or so.
Oh,
Yeah, it's I'm using
which is a library for machine learning in Python. And there's an example in the official TensorFlow library called Deep Dream. And so I'm starting with that and then adding my own tricks to it.
Very cool. Thank you. Other questions?
Yeah, I wanted to ask about
Wait.
practical application. If there is something like that's being done practically beyond just art, what are the different practical applications you can think some of these techniques could be used at?
Well, for example,
for generative,
there's a lot of practical applications. One is, in a lot of circumstances, you need to be able to generate graphics, like let's say for video games and for content delivery systems and for articles. All of that stuff needs to be able to generate graphics. Another useful thing of generative models is that you can use it to, a lot of AI agents that we want to make have to be able to sort of simulate, to be able to kind of try to figure out what's going to happen. They have to have a model of the world, basically, in order to simulate, imagine possible scenarios, and then pick one that it favors. And so this is something that you would accomplish with generative models, because they're able to be used for simulation, because they generate the world. There's lots of others, like generative models for audio are the basis for speech to text to speech systems. So like when you speak to your phone and speak back to you, there's a generative model that's being used, and it's not that different from the stuff that I've shown. So those are kind of the more practical applications, I would say, and there's lots of others, of course. Yeah. Good question. Mm-hmm. Any other questions?
Yeah, thank you. Yeah, we've got another one here.
Was the project of synthesizing the painting real time and with a sensor, or only with a natural camera?
Okay, can you repeat that maybe?
Yeah, again.
Is the one the project with the styling of the artist a real time with only a camera, or with also a Kinect or a sensor, some type of something?
The question was when I'm synthing, I think that would be like I think of a different part. Was there a Kinect involved? Is that correct? So none of
Yes, it's just a sensor or only a camera?
I don't think I used a sensor. I think it was all just images. Yeah, I do stuff with sensors, but none of the stuff that I showed uses it.
Images.
So is it just images only?
It's images, yeah. All of the stuff comes from images, data sets of images.
Okay. Any other question?
Mm-hmm.
I wanted to ask if the same tools and logic could be used to like applications that's not just visual representation. So some of the applications that you mentioned does not seem to only rely on like visual generation. So is it the same tools and frameworks? So it's going to be TensorFlow, like the same concept. If I want to generate that for, let's give an example. I'm building an artificial intelligence personal assistant. And I want this personal assistant to understand and generate ideas about the world. Do I use the same tools, or there are different sets of principles and tools that I need to use with that form of like application that's not exclusively visual?
You would use different tools that might be optimized more for those different kinds of media. So there's definitely, all of these tools exist in the audio domain also, and also in the text domain. But they use very similar techniques. So the great thing about deep learning is that it's very much like it can be used for multiple kinds of media. So it's not just images. Similar techniques, but they do need to have some changes to work in for text, let's say. So there have been really, really excellent, interesting generative models for text. Yeah, but right now they're not. Right now, not. Well, I mean, there may be like the images are always a little bit farther ahead, but definitely the text and audio stuff is actually quite good.
Right, cool.
Mm-hmm.
So Ed, yeah, no one?
Yeah.
Yeah, another question here. Yeah.
Yes. Sorry for asking.
Yeah.
The one with the Van Gogh Starry Night.
Mhm.
Is it the training is only with this painting only?
Which one?
Which one? The Van Gogh?
The Starry Night.
The
The
Starry
Starry
Night.
Night, yeah.
Is
Is using a technique.
It's
It's
using
using a
a technique
technique transfer.
and it actually doesn't require training. So yeah, it is based off of just one painting. Now there's a model that was trained on many paintings besides for Van, and that model is trained in order to kind of recognize features of painting. But the style transfer technique, it does not need to be trained on a single painting. It just uses that painting as a sort of objective. And so it works without needing more than one painting as a target.
Could you just please repeat the name of the technique again?
Style
transfer.
Style transfer.
There's a few ways to do style transfer. You can't do it like your own network. But the ones that I showed were actually just using different techniques that don't require training on many paintings. That Volkswagen picture of a Volkswagen.
Again, sorry, the sound just
There's a
dropped.
bus. I think I see. Maybe not.
Sorry, because you just need to put the mic on and off all the time to ask questions, so it's taking a bit more time. Yeah.
It's just if I want to get it started in that, if I haven't really executed any projects before, and I'm not an intense coder, like I have like some coding background, but in web interfaces, what are the first exercise that I should visit so I would experiment with the frameworks and would produce something as an experiment with technologies and the whole concept of generative design. So what is the step number one that I should go through if I have some technology background, but I'm not trained on these tools?
So there's a couple things I would recommend. One is I've been working on this website for a couple of years, ml4a.github.io, and that has a lot of resources for beginners to get started with creative machine learning, especially in the guides, the instructional guides. There's also two other projects I would recommend. One is something called Runway. Runway is this application. You can find it online, like Runway app, that does basically machine learning in a very easy to interface kind of way. It's a really, really good program. I'm joining Runway in some capacity right now, and they're really making it a lot easier to use. Right now they're in a private beta, but they're going to be in a public beta at some point this month. So it's actually going to be really soon. Another project I would recommend is the ML5 project, and that is, especially if you're a web developer, that shows you how to do machine learning on the web using TensorFlow.js. It's all JavaScript, and lets you kind of create games and interactive web applications using neural networks. So I would say those are the best places to start.
Sorry, they are asking again, what's the name of your program?
ML4a.github.io. So I think Mohammed probably has the link. It's just the letters ML4a.github.io. But I think Mohammed probably has the link, and I'm sure he can share it with.
Yeah, sure.
It's also on my website.
Yeah, sure.
Thank you.
Thank you so much.
Yes, thank you.
Yeah, it's been a pleasure having you.
Have a really nice night where you are.
Yeah, thank you. Have a good night. You too.
Yeah.
Thank you.
Thanks.
Thanks a lot for your time. See you soon, hopefully.
Yeah, thanks a lot for having me.
Thanks a lot for having me.
Have a good night.
Have a good time. You too. Bye.
Bye.
Cool. So, we should end the call, yeah.